Alright, moving forward with our game project, the next class to address is the enemy class. This class is going to contain both the state of the enemy itself, and it's also going to establish the concept of a sight radius. We're going to set up an enemy that has a fixed radius that counts as the sight radius, meaning if we are outside of this radius, the enemy cannot see us, and will just continue whatever it was already doing. If we venture close enough to the enemy, then the enemy will realize that we exist and begin chasing us. So we'll need to establish this concept of how far away we have to be from the enemy before he can see us. So to get started, let's jump over to the enemy class. Before we jump into the class itself, let's establish the different states that the enemy can be in. We'll do this using an enumeration. So we'll set up an enum called enemy state, and then we'll add a series of elements to this enumeration. There are going to be 3 different states that our enemy can be placed in. First, we'll have a wandering state. So we'll make a state of wander. Next, we'll have a state of seek player. And finally, we will have a state of seek health. At this point, let me give a quick overview of how the gameplay scenario will play out. When the game begins, the enemy will be placed into a wandering state. This state will cause him to simply wander to random path nodes one after another throughout the level. So that way we get motion from the enemy as he simply randomly searches the map. If the player wanders close enough to the enemy will recognize the player and begin chasing him. His state will then change from wander to seek player. So the enemy will continue to seek the player until he catches the player. The moment he catches the player, the moment he actually collides with the player actor, we will assume a scenario of, pretending that we had done some devastating blow to the enemy and destroyed all of its health. At that point, we will spawn a health power-up and change the enemy's state to seek health. So after colliding with the player, he'll then turn around and search for and find the health power-up. Once he picks up the health power-up, we will change his state back to wandering so the scenario loop can begin over again. Alright, now we need to jump into the enemy class so that we can both give it the ability to remember its state and also establish its sight radius. So inside of the enemy class, we'll begin with the first field, which is going to be our enemy's state. This will be a public field. It will be of type enemy state, and we will set the enemy state to an initial value using a field initializer. We'll set an enemy state of wander as our default state. We also need to give a name for the state itself, so let's call this simply state. Alright, now that we have our enemy's state field, let's also add a field that will represent our sight radius. We'll make a public floating point field called sight radius, and we'll set it to a default value of 128. Again, this will be the radius outside of the enemy actor that it can see. Alright, moving on from here, we're going to add a method that will give ourselves a formal way of changing state. We're going to put together a change state method that will give us the ability to do things, if we wanted to in the future, do things other than simply changing the state itself, or to cause effects upon the state change. So we will make a public method with a void return type called change state. We will take in a new state as a parameter, so we will create an enemy state parameter called state. Inside of change state, we're simply going to take our current state and set it to be equal to the state we had just passed in. So enemy.state will equal state. Now once again, this gives us a scenario where we're actually telling the enemy to change its state, and it also gives us further room for expansion where we can cause things to happen in addition to the changing of the state itself. Alright, moving on from here, we're going to add an auxiliary method to the enemy class that will allow us to visualize its sight radius. In order to make it easier to design and tweak the enemy's behavior, we're going to draw a circle with the radius given by sight radius. This will make it easier to test the scenario since we can see how close we have to get to the enemy before the enemy will start chasing us. So we're going to put together a method that will allow us to draw a circle using the sight radius as the radius for the circle. We'll put this method together as a private method with a void return type, and the method name will be drawCircle. We'll take in two parameters to the method itself. First is a sprite batch to use when drawing the circle. So that will be a parameter of type sprite batch. We'll call the parameter sprite batch. And we will also take in a radius to use when drawing the circle. So we will take in a float called radius. Alright, now inside of this method we need to draw a circle. In order to do this, we're going to use what is currently the only circular graphic that is filled inside of this example, and that is the node graphic. Now what will happen in this case is since the node graphic is relatively small, a lot smaller than a radius of 128, we'll end up stretching this graphic out as it draws. This will result in some fuzzy pixelated edges around the outside of it. This could be corrected by either creating a larger graphic or simply using the drawCircle method purely for debug visuals, which is how we're going to use it. Now we need to put together some code that will allow us to draw a circle with the given radius. In order to do this, we'll have to take into account that the texture itself already has a radius. Again, we'll be using the node texture, so we'll have to deal with its radius of 8. Before we draw, we'll also put together a color variable to use along with the drawing. So here briefly, before we deal with the radius itself, let's make a color variable called color, and we will set a color of transparent white for use with this drawing overlay. So we'll set a new color of red components of 255 in red, green, and blue. Then we will specify an alpha of 80. Alright, now that we have the color established, let's tackle the radius. In order to calculate the radius, we first need to know the size of the texture itself. We'll also hold a reference to the texture to give a single point that we can change, since we will need to reuse this reference as we calculate and then draw. We'll make a texture2D variable here called texture, and we will copy the reference to the node texture. So that's style.nodeTexture. Alright, now that we've established our texture, let's find the texture's radius. We are going to assume the texture we're setting is a circle, so we will measure half of the width, and we'll call that the radius of the texture. So we'll put together an integer called texture radius, and we will call, or rather calculate this as texture.width divided by 2. Alright, now that we know the texture's radius and we know the incoming radius to draw, we need to find the ratio between these two. To do this, we'll establish a scale variable. So we'll put together a float called scale, and we'll set this to be equal to the incoming radius divided by the texture's radius. So that's texture radius. The idea here is, let's say we had specified a radius to draw as 16, and our texture's radius was 8. In that case, radius divided by texture radius would be 2. That would give us a scale of 2, so we would scale our 8 radius texture up by 2, giving us a radius of 16, which would be the requested radius. Alright, before we draw, let's also put together an origin so that this radius can be drawn centered on an actor, and actors themselves are centered around their origin. So let's make a vector2 called origin, and let's set that to be equal to the center of the texture. We'll assemble a new vector2. We already have the center of the texture established as texture radius, so we'll simply plug texture radius and grabbing the name radius. So texture radius by texture radius. Alright, with our origin in place, we can now begin the drawing operation. We will use the incoming sprite batch. We will invoke the draw method. First, we will pass in our texture variable. We need to give this texture a position. We'll draw the texture at the position of the enemy itself. So here inside of the enemy class, that would be this.position. We'll draw using, let's scroll through some of our overloads here. We're actually going to be drawing using the 6th overload of draw, meaning the next thing we need is a source rectangle. We're not using one, so we'll specify this as null. To give a color, we'll specify the color created as the color variable earlier. We need to specify a rotation. We'll give a rotation of 0. We'll drop in the origin using the origin variable. We'll give a scale using the scale variable. We'll set sprite effects to none. And finally, we'll give a layer depth of 1. We'll set a value of 1 here to give this site radius overlay the highest priority possible. This will actually be higher than the actor itself, which is desirable so that it always draws on top of the enemy actor in addition to everything else drawn in the scene. Alright, now that we have a method put together that will allow us to draw a circle, let's incorporate that method whenever the enemy itself draws. To do this, we will override the enemy's draw method. Then after the call to base.draw, we will add a call to draw circle. We'll pass in the sprite batch that was given to the draw method, and we will specify a radius as site radius. So that way we can get a visual representation of the site radius itself. Alright, with all of these things in place, that's all we need to do for the enemy class. So let's now turn back over to the game class, the scene game, and let's instantiate an enemy. We'll drop in here right below the player, and we will say that the enemy field is going to be equal to a new instance of enemy. We'll position the enemy in the bottom right-hand room of the level. We'll do this by setting our enemy's position to a value given as a new vector 2, with values 550 in x and 450 in y. We will also set a speed for our enemy. We'll set the enemy speed, or enemy dot speed, to be equal to a value of 2. Now we can run the game, and we should see a new enemy created in the bottom right-hand room. So if we build and run, we see there we have our enemy. We can see a fuzzy white halo around this enemy representing its site radius. You'll also notice that even though the enemy has been given a speed, it is not yet moving. This is due to the fact that the enemy's direction has not yet been set. And we won't worry about setting its direction. We'll worry about that when we begin putting its behavior together. So up until now, we can see the main thing is the fact that we have this visual site radius around the enemy itself. And once again, this will be very nice as we can see how close we need to get to the enemy before the enemy will start chasing us. If you look really closely at the edges, you can also see that they are very pixelated since we're using simple blending on it, and you can actually see the pixel edge off on the sides. Again, if you wanted a nicer looking texture, since the code already adjusts in size, you could simply come up with a larger version. For example, a 64 by 64 texture would look significantly better, and a 256 by 256 texture would give you native pixel for pixel resolution. But again, since this is only a debug visual, we'll continue using the small 16 by 16 texture. So with this enemy now in place, we have the enemy class complete, and it is time to move on.